Okay, today's aim is how do we prove lines are parallel? So before we do that, let's review a postulate that we learned about two parallel lines cut by a transversal. And the postulate went as follows. If a transversal intersects two parallel lines, so line L and M are parallel, and here's T, my transversal. If transversal T intersects lines L and M, these parallel lines, then corresponding angles are congruent. Then angles 1 and angle 2 are congruent to each other. So what we're going to do is we're going to form the converse of this, and this of course should be in your notes. And the converse says if two lines and a transversal form corresponding angles that are congruent, in other words, line L and M are just two plain old lines, and they are intersected by this transversal, and if the corresponding angles, if angle 1 is congruent to angle 2, then these two lines, line L and M, are parallel to each other. So let's take an example. Find a value of x for which line L is parallel to line M. In other words, what value of x would make these two corresponding angles congruent? Let me find a value of x that would make these two angles, this angle here, that would make this angle and this angle congruent to each other. Because once I do that, if I can find the value of x that would make these two corresponding angles equal, well, what does it say? If two lines and a transversal form corresponding angles that are congruent, then the two lines are parallel. And what they're asking me to do is find a value of x for which line L is parallel to line M. For which. So this basically is the same thing. It means the same thing as that would make. Find a value of x that would make the corresponding angles equal. If I can find a value of x that makes these corresponding angles equal, then line L and M would be parallel to each other. So let's see how I do that. Let me set x plus 25 equal to 55, and let me solve for x. So I'm going to subtract 25 from both sides of my equation. Okay, and I'm going to get x is equal to 30. So a value of 30 would make these two corresponding angles equal. Well, if these two corresponding angles are equal, what do we know about the lines that the transversal intersects? It must be true that these two lines, line L and M, must be parallel. So my answer is x equals 30. Let's take another example. Let's remind ourselves of another theorem having to do with parallel lines cut by a transversal. And that was theorem 3-1. If a transversal intersects two parallel lines, then the alternate interior angles are congruent. So in other words, if lines A and B are parallel, then angle 1 and 3 are congruent to each other. What is the converse of this? The converse is if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. In other words, if this transversal creates alternate interior angles, angle 1 and angle 2, that are congruent, then line L must be parallel to line M. So how would I be asked to solve a problem? Let's take an example. It says find a value of x for which line L is parallel to line M. Again, for which is just code for that would make. Find a value of x that would make the alternate interior angles equal to each other. Find a value of x that would make these angles congruent to each other. Well, let me set 2x minus 5 equal to 95. So 2x minus 5 equals 95. And I'm going to find a value of x that would make these two angles equal. And if I can find that value of x, then lines L and M would be parallel. So I'm going to add 5 to both sides of my equation. And I get 2x is equal to 100. And dividing both sides of my equation by 2, x is equal to 50. So a value of 50 would do what? It would make these alternate interior angles congruent to each other. And based on what we just learned, if alternate interior angles are congruent, then the two lines are parallel. If angles 1 and 2 are congruent, then line L and M must be parallel. Well, if these alternate interior angles are congruent, and I found a value of x that would make them congruent, then line L and M would be parallel. So a value of 50 for x would make these two alternate interior angles congruent and would therefore make lines L and M parallel. Let's take a look at another theorem we learned. We learned that if a transversal intersects two parallel lines, then the same side interior angles are supplementary. So if A and B are parallel, and they're showing that to us there, A and B are parallel. If they are parallel, then the same side interior angles, angles 1 and 2, are supplementary. So what is the converse of that? Well, the converse of that is if two lines in a transversal form same side interior angles that are supplementary. In other words, if 4 plus 2 are supplementary, if 4 plus 2 are equal to 180, then line L is parallel to line M. So let's take an example. Okay, this one is a little more challenging. This 5x, although it could be used, is going to be very difficult to use. One of the things I do know is that right here I have vertical angles. So these two angles over here are vertical angles. Let me see if I can highlight that. So this angle here and this angle here, these are vertical angles. So if this angle is 5x plus 40, that means this angle must also be 5x plus 40. Okay, well, notice what I have here is I have two same side interior angles, 2x and 5x plus 40. If I can find a value of x that would make these two same side interior angles supplementary, then line L would be parallel to line M. Again, because these are vertical angles, if this angle is 5x plus 40, then so must this angle be 5x plus 40. That's the vertical angle theorem. So you'll also notice that if this angle is 5x plus 40 and this is 2x, these are same side interior angles. Same side interior angles. If two same side interior angles are supplementary, according to this, if two same side interior angles are supplementary, then the two lines must be parallel. Well, let me find a value of x that would make these same side interior angles supplementary. In other words, let me set up an equation that goes like this: 5x plus 40 plus 2x is equal to 180. Let me find a value of x that would make these two angles supplementary. Well, 5x plus 2x, which is 7x, plus 40, let's make that look nicer. So I have 7x plus 40 is equal to 180. I'm going to subtract 40 from both sides of my equation. Subtract 40 from both sides of my equation. So I have 7x is equal to 140, right? And 7 goes into 14 twice. 7 goes into 140 20 times, right? So if I divide both sides of my equation, let me divide both sides of my equation by 7, and I get x is equal to 20. So a value of x would make these same side interior angles supplementary, which would make lines L and M parallel. So that's how you do proofs for proving two lines cut by a transversal are parallel lines. Let's take one more. So let's take this one. The converse of the same side exterior angle theorem. We learned that if two parallel lines are cut by a transversal, same side exterior angles are supplementary. Well, the converse is if two lines on a transversal form same side exterior angles that are supplementary, then what? Then the two lines are parallel. In other words, if angles 1 and 3 are supplementary, then lines A and B are parallel. Let's take an example. Actually, this is alternate exterior angles. That's okay. So let's do the alternate exterior angle converse. So if two lines are cut by a transversal that form alternate interior angles that are congruent, then the two lines are parallel. So if I can find a value that would make angles 1 and 2 congruent to each other, then the two lines A and B would be parallel. So let's take a look at this. So these are definitely same side. These are definitely alternate exterior angles. These are not same side exterior. These are alternate exterior. Sorry. This is alternate exterior angles. If alternate exterior angles are congruent, then the lines would be parallel. Find a value for x for which line L is parallel to line M. In other words, find a value of x that would make these alternate exterior angles congruent to each other. So let me set up my equation. 3x minus 33 is equal to 2x plus 26. Let me find a value of x that would make these two angles congruent, these two alternate exterior angles congruent. So I'm going to subtract 2x from both sides of my equation. So I subtract 2x from the right side, subtract 2x from the left side, and I get x minus 33 is equal to 26. And when I add 33 to both sides of my equation, I get x is equal, 33. I get x is equal to 59. So a next value of 59 would make these two alternate exterior angles congruent to each other, which would therefore make lines L and M parallel.